Hello everyone, my name is Max Aronson and this is Vidhi and I.
Hello.
We are going to tell you about our mission to Mars.
Barack Obama said, by the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. This project was assigned to us by our biology teacher, Mr. Zhang, and we have given a great amount of thought and work into this.
Our job was to create a shuttle to send 4 astronauts to orbit Mars and supply them with enough life support to allow them to arrive safely back to Earth.
We wanted to keep the shuttle as realistic as possible, incorporating just enough science fiction with enough reality to make this project as feasible as possible.
To start, we wanted to address the problems that were prevalent in this process. These problems include food, water, air, the shuttle itself, the time it would take to get there and back, as well as sustaining the ship and the astronauts for the amount of time it would take.
Now, Max will let you know about how we dealt with these problems, and I will tell you about our final processes for this project and how we solved these problems.
To create our project, we wanted to solve all problems that the astronauts would encounter on this journey to Mars. We wanted our research to be as detailed as possible before talking to Mr. Zhang, so this is the process we went through. By isolating what our problems were, we were able to organize our solutions. The first problem is supplying the astronauts with food, because obviously they need to eat. We want a sustainable food source that can continuously produce food. The solution that Vidhi and I found to this is to make a garden where we can grow high-calorie crops such as peanuts and soybeans. In addition to this, we would have supplemental vitamins and dehydrated foods to fulfill the astronauts' nutrition. The garden would be in a rotating chamber in order to make artificial gravity through centripetal force. The fertilizer to the plants would be the solid excrements of the astronauts, because feces actually have about 90% of the energy that humans cannot access. This can ensure a sustainable cycle of energy. The next problem we needed to solve was to hydrate the astronauts and give the plants water. Along with the water that will come as a byproduct from the hydrogen fuel cell used for energy, which I will go into later, water will come from urine. By putting urine through reverse osmosis, the H2O can be extracted and used to hydrate the astronauts. The water will also go to the plants. The additional ammonia that comes from the urine will be put through nitrification to make it nitrates for the plants. That actually solves a few problems. The next problem is to supply an atmosphere with proper gases and oxygen for the astronauts. The source of this oxygen will be from the plants. In addition to the plants in the garden, there will also be algae growing. Algae produces 75% of the world's oxygen, so we will use its oxygen-making magic to support the astronauts. For the problem of the physical shuttle, we wanted to make it aerodynamic and to stop radiation from infecting the astronauts. Both of these problems Vidhi will go into. We found out that the trip would take 243 days in total, so we calculated the amount of plants we needed in our garden around that. Finally, in solution to sustaining the ship, we will make a hydrogen fuel cell from which the main byproduct would be water. This water can be used to nourish the astronauts and the plants. Mr. Zhang suggested that we put more thought into how the fuel cell worked, so we are in the process of doing so. In addition to the fuel cell, we will capture the unlimited resource of sunlight with solar panels and solar sails. Vidhi will now show you what the spaceship will look like, as well as some changes we made after talking to Mr. Zhang.
Hello, I'm Vidhi, and I'm here to talk to you today about our model and also the final process that we took to achieve this model. Due to the difficulty of making every small aspect of it, we just made the general area. Now, as you can see here is the workspace for the astronauts. There isn't much here because there really just is a workspace. And over here will be where the garden is, which is this circular area right here. And I'll show you a close-up of that later. And then right here, the back part, is where the bathroom and where the hydrogen fuel cells will be. And the bathroom can be seen right here, which is this white part. Now you may be wondering what this black tube is. It's a pipe that's connecting every single aspect of the ship together so the astronauts can walk about it. And we made this because our teacher, Mr. Zhang, said that one of the things that we need to focus on when finishing up this project was to tie everything in together. And because of this, we decided to make a pipe right in the center so it's easy for the astronauts to access everything. Now, another thing to notice is the garden. Well, Max explained it before, but I'll show you how it would look. As you can see, there are hexagons over here to hold more soybeans and peanuts. And this right here is the black tube that I showed before. Now, the final thing that Mr. Zhang said that we need to really focus on was how to turn the ammonia into nitrates from our urine, or the astronauts' urine. And Max did some research to help us find this solution, and we had to go through nitrification. The ammonia does, at least. And that was the main thing that Mr. Zhang said to focus on, and also to tie in everything together, which was the garden, the ammonia, also the rest of the bathroom components, and also the hydrogen fuel cells, and how they all work together. And if you realize this, the hydrogen fuel cells, which will be located right here, they create the water, which will water the garden and also the astronauts. And the bathroom, right here, will provide some fertilization for the garden, and that will be the waste product of the astronauts, so nothing is being wasted. And now the garden, for example, that's being used to feed the astronauts, and then the cycle is just pretty much never ending, and the fuel cells themselves will help fuel the entire ship. And this was mainly the final aspect that we had to think of when finishing up the design of the ship, and also all of the creative parts of the ship. And that's pretty much what our teacher told us to do, and that was the final step that we took to finish up this project. Now, we hope that you understood everything that we said, and also we have a website in case you have any more questions or just wonder anything else. And like I said before, the final process that we took was to relate everything to each other, which we may not have done that well before, but I hope it's a lot clearer now. Thank you for your time, and let's go to Mars!